Good evening, everyone. All right, so this evening's topic, we're going to look at circle theorem. Now, circle theorem, we have several theorems or several rules that help us in identifying missing angles when it comes to angles within a circle. Right? So these theorems or rules, they are taught all together because when it comes to the questions may come all together. Right? So they may come where you have to apply several theorems to one question in order to find the missing angles. Now, there are some basic facts that we must be able to take away when it comes to circles. Right? So we have some things we must know. Right? So when it comes to the circles, you already know that the distance around the circle is known as your circumference. Right? So let's pretend you're walking around a circular field. From the start, walking around and ending where you started, that distance around or the perimeter has a special name which is known as the circumference. Right, so you have the circumference, which is the distance, the total distance around the circle. Right, so it's a total distance around the circle. Now, if you have a part of a circle, if you have a part of the circumference, which is not the entire circumference, a part of it, we call that an arc length. Right, so the arc length is a part of the circumference. So when you hear the term arc, an arc, you know it is a part of the circumference. All right, so we're looking at circle theorem, and there are certain parts we must know. Right, we already know that the diameter is that line that is drawn through the center of your circle connecting 2 points of the circumference. Right, so this here is your diameter. Right, so we're just taking a note of some important parts, because when it comes to circle theorem, all of these terms apply. Right, so your diameter that's the line through the center of the circle. Right, so the line through the center of the circle connecting 2 points of the circumference. right? So that's the diameter. Then you have your radius. Your radius is from the center to any point on the circumference. Your radius is actually half of your diameter. You must know this, right? So you have your radius, which is half of your diameter, right? So it's half of the diameter, and it's a line from the center of your circle to any point on your circumference. All right. Then the next step is you're going to have a sector. Now, think of a sector as your slice of pizza, right? So a sector is basically that region that is bound by two radii. So you have one radius here and another radius here. So it's bound by two radii and an arc length. So that's your sector. Right, so we can define the sector as well. Right, so it looks like a slice of pizza, and it's bound by two radii. That's the plural of radius, and an arc length. Or I could just say an arc. Now, the smaller slice, that's called a minor arc. But if I look on this end here, look at what I'm retracing in, I wonder if I could see it in green. If I look at what's in green, right? So if I look at this part, so I have one radii here, one radii here, and I also have an arc length around here. So this region in green is also a sector, but this part is known as the major sector. Right, so this is your major sector, and the smaller part is known as your minor sector. Another thing that you must know is the term chord. A chord is a line which cuts a circle into two segments, right? So it's a line that connects from one part of the circumference to the other circumference, but the difference is it doesn't go to the center. If it goes through the center, then it's the diameter. But if it doesn't go through the center, then it's not the diameter. We call it simply a chord, right? So let's define the chord. Now in circle theorem, they use all of these terms, right? So we have the chord, right? So the chord, that's a line which connects 2 points of the circumference, but does not go through the center of the circle. It divides or circle into segments. Right, so it divides the circle into segments. Right, so if we look at this, we have the smaller segment, which is what we'll call the minor segment. And then the bigger segment, we'll call that the major segment. All right, so let's look at the first theorem or the first rule. Now, anytime we have a chord, right? So this chord could be this way, this way, this way, or even this way. It doesn't matter. Once you have a chord and you have an angle subtended by an arc, right? So we may have a chord and then the angle, right? So you might have an angle being formed nearer your circumference or on your circumference. Now there's a rule for this one. If we have several of them coming off of the same chord, right? So if we have these angles coming off from the same chord, this same chord, all of them coming from one chord, then the angles at the circumference within the same arc are all the same. Right? So the first theorem is going to be angles sitting on the same chord are equal. All right, so what this means is that, let's say this is 50 degrees. It means that this angle here will also be 50 degrees, and this angle here will also be 50 degrees. Once they are sitting on the same chord or standing on the same arc of the circle and within the same segment, they are equal. All right, so let's look at some different ways they could bring this one. So let's say they brought it like this one. So let's say they gave you one like this one, and they told me that this is A and this is 50 or whatever degrees, it can be 75, 38, whatever. Now, if you notice, both of these angles are coming off of the same chord, which is this one. So once they are on the same chord within the same segment, they are equal. So that means A will be 50 degrees. All right, so that's theorem 1. Yes, you can draw them. Tell me once you have them. All right, so let's look at the second theorem. Now, please remember, I'm not doing it in a particular order. So if it is that you are asked to give a reason, you do not just say according to theorem 1 or according to theorem 2, right? There's not like a particular order with respect to the numbering. So what you have to do is you have to know the theorem itself, which is this part. So if you have to explain it, you have to give this part. So with theorem 2, it shows that if it is that I have two angles, right? So if I have two angles, one angle extends onto the circumference and one angle going towards the center. That doesn't look centered. Right, so you have your center, let's say the center is here. Right, so you have one angle coming off of the center and one angle extended onto the circumference. Now the rule is, anytime this occurs, the angle at the center of your circle is twice the size of the angle at the circumference. So if this is 2x, the angle here will be x, right? So it's twice the size of that extends onto the circumference. All right, so let's take a note of that theorem. All right. So the angles would stand on the same chord. Right, so these angles here are standing on this chord here, where one subtends to the center and the other subtends to the circumference, show that the angle at the center is twice the size at the circumference. So that simply means that, let's say I have this, and maybe we have a chord like this, where one angle is extended or subtended at the center, while the other onto my, could be any, it could be any direction. Once it's subtended, one to the center, one to the circumference. The angle at the center is twice that at the circumference. So if this is 60 degrees, this one will be half of 60, which is 30. All right, so we're taking this one down as well. All right, so let's look at theorem 3. Now, theorem 3, we're going to look at it where the angles are coming off of the diameter. Right, so these angles are subtending off of the diameter. Right? Angles within a semicircle. So if you have angles within a semicircle, the angles which extend or subtend onto the circumference are 90 degrees or right angles. All right, so these angles, once it's coming off of the diameter, they are right angles or 90 degrees. So let's take the third theorem. Again, it's in no particular order. Right, so angles within a semicircle, the angle in a semicircle is a right angle or 90 degrees. Right, so we have this rule. Then we're going to look at another theorem. Or let's see if we could try this one for me. So let's try this one. I'll put it in another color so you can see it clearer. So let's try this one for me. So you have the angle coming off of the diameter. And let's say they gave you this angle. They told me this is A, this is B, and let's say this here is 37 degrees. So let's say they asked us to find A and B. Let's try this one and give me your answers in the chat. All right, so for this one, what we have to remember is that this angle is coming off or subtending off of your diameter. So once it's subtending onto the circumference from the diameter, that angle is 90 degrees. So that means that A will be 90 degrees. Now, this is a triangle. Angles of a triangle must add up to 180 degrees. So if we add the angles that we know, So that would be 90 plus 37. And then we subtract it from the 180 degrees, we will get the angle of B, right? So it pulls all of the rules. Your rules when it comes to parallel lines and all. Every rule that you know, angles of a triangle, straight line, everything, everything. It's going to pull all of those angles rules together. Right, so let's see this one. So 10 minus 7, that will be 3, 7 minus 2 is 5. So that means that B will be 53 degrees. Right, so besides the theorem, you have to use your regular rules as well. All right. So let's just make the corrections quickly and let's look at the next theorem. Tell me if you guys understand. All right, so let's try another one. So same rule being applied. All right, so let's say they gave us, this has 52. And they asked us to find A and B. Let's try this one. All right, so this angle up here is 52 degrees. All right, so let's try this one for me. All right, so 52. And then they asked us to find A and B. Let me know your answers in the chat. Let's see. All right, so the angle which subtends off of the diameter, right? So the angle at that circumference is going to, that point in the circumference, that's going to be 90 degrees. So A will be 90. And then it's a triangle. Angles of a triangle must add up to 180 degrees. So we'll add the 90, we add in what we know. So that's the 90 plus the 52. And that's going to be 142. Then we have to subtract that from 180. Right, so we'll get 38 degrees for B. Ada, check it over for me. Right, so B is 38. Right, so it was 90 plus 52, we got 142. And then when we subtracted, I got 38. All right, so another theorem I'm going to look at. Okay, I understand. All right, so let's look at another theorem. Now, anytime you have a quadrilateral, Remember, quadrilateral is a four-sided figure. Anytime you have a quadrilateral within a circle where each point of the quadrilateral touches the each point of the circumference of the circle, we call those a cyclic quadrilateral. Right, so theorem number 4, we're going to look at cyclic quadrilaterals. Now, cyclic quadrilaterals, remember, this is where a quadrilateral is within the circle and every point of it touches the circumference. Right, so for each point, it touches the circumference. Now, once this is the case, your opposite angles are supplementary. Right, so opposite angles are supplementary. That means they add up to 180 degrees. Right, so your opposite angles must add up to 180 degrees. So that means that, let's say I have these angles of this quadrilateral. It means that your opposite angle must add up to 180. So that means these two, when I add these two, it must equal to 180 degrees. And if I add these two, they must add up to 180 degrees. All right, so let's take down this one and then we'll clear to try some. Now, there are several other theorems, but we will complete them in our next class. So we'll stop up to this theorem. We'll practice some after. And then in our next session, we're going to continue. All right, so tell me once you have this down. All right, so let's say they gave us one like this one. And they told us that this is parallel to this line. Here is 112 degrees. And they gave us here Z, here as X, and here as Y. Now, what you have to recall is besides the different theorems, you must apply all of your rules when it comes to your parallel lines, all those rules of parallel angles, straight line, vertically opposite lines, etc. Now, they gave us this angle here as 120. Now this, we can see it's a straight line. So I can use this in order to find this missing angle here. So that's going to be 180 minus 112. Right, so 180 minus 112 is 68. So this angle here is 68 degrees. Now, opposite angles are equal. Sorry, not equal, but supplementary. Right, so opposite angles are supplementary, which means that this plus x must amount to 180 degrees. So 180 minus the 68, that's 112. So x is 112 degrees. Now, this line, I'm outlining it in black, is parallel to this line. Anytime you have a line across parallel lines forming interior angles are also supplementary. So if here is 112, it means that here would be 68 degrees, right? Because it's 68 plus the 112 will be 180. And then these angles here are opposites. Opposite angles are supplementary, so that means that this angle here is also going to be 112 degrees. All right. Now, it just means that we have to look out for all of those rules in order to ensure that we get them. All right, so what we're going to do in next class is we're going to continue looking at all of the other theorems, and then we're going to practice them using past paper questions.